Hello again. Today we're going to build on our knowledge of geometric series by talking about infinite geometric series that go on without ever ending. All right, so let's remember what we learned about geometric series. If the first term is called U1 and the common ratio is called R and the number of terms in the series is N, then this formula gives me the sum of that geometric series. So we've learned that in a previous lesson. And sometimes they call U1 A, but just get used to both of those notations. Sometimes it's called A, sometimes it's called U1. All right, now imagine having an infinite number of terms. Well, if the absolute value of R is greater than 1, then the terms keep getting bigger and bigger and bigger, so the sum of them is going to diverge. But if the absolute value of R is less than 1, then the terms get smaller and smaller and smaller, and the sum will actually become a finite number. And the way to calculate that number is to just get rid of the parentheses that were on top of the original formula, and the sum is going to be U1 over 1 minus R. So for example, we're going to find the sum of the series 2 plus 2/3 plus 2/9 plus 2 over 27, and so on. That series goes on forever. All right, and so we need to find two things for each of these geometric series. We need to figure out what the first term is, and we need to figure out what the common ratio is. So the first term is 2. I can just look at the series and figure that out. To figure out the common ratio, all I need to do, if I know this is a geometric series, all I would need to do to figure out R is to take any term in the series and divide it by the term that comes before it. So I could take 2/3 and divide it by 2, or I could take 2/9 and divide it by 2/3. Any term and divide it by the term that comes before it. So if I do that, in either case, I'm going to get that the common ratio is 1/3. That does have an absolute value that is less than 1, so this series does converge to a finite number. It does not diverge. So the sum, if I plug that into the formula, is going to be 2 over 1 minus 1/3, and that is going to be 3. So even though that series does go on forever, the entire series adds up to 3. All right, here's another example. I have 4 minus 12/5 plus 36 over 25 minus 108 over 125, and so on. So the first term again is 4. I can just look at the series and figure out that that is 4. Again, to figure out R, I take any term and I divide it by the term that comes before it. So I could take negative 12/5 and divide it by 4. I could take positive 36 over 25 and divide it by negative 12 over 5. No matter which two terms I choose, I'm going to get a common ratio of negative 3 over 5. So I have my U1 value, I have my R value, and I can plug them into the formula and get that the sum is going to be 4 over 1 minus negative 3/5, which ends up being 5/2. So that sum adds up to 5/2, or 2.5. So let's look at an application of this. If I wanted to take a repeating decimal and convert it to a fraction, what I could do is I could write it as one significant digit at a time. So 0.07777 can be written as 0.07 plus 0.007 plus 0.0007, and so on, because that is a geometric series. The first term is 0.07. And if I take any term and divide it by the term that comes before it, I will get 0.1. So I have my U1 value, I have my R value, and I can plug those into the formula and get that the sum is 7 over 90. And if you wanted to check that, you could type 7 over 90 into a calculator and convert it to a decimal, and you would certainly get 0.07777 repeating as your answer. So this is a further discussion of geometric series and talking about infinite geometric series. Sometimes the series does diverge, but sometimes it does converge to a finite number. So if you have any questions about that, please let me know, and I will see you tomorrow.